All right, we're in Chapter 10, Lesson 3 today, and we're going to be talking about geometric sequences and series. We're going to start off with a key concept for how to define or find the nth term of a geometric sequence. And basically the process for this is you're going to take, to find any nth term, you're going to find the first term and multiply it by the common ratio raised to the n-1 power. So if you wanted to find, for example, the 10th term, you'd be raising it to the 9th power because you're doing the term minus 1. All right, moving forward, first example, we need to find the 6th term of a geometric sequence when the first term is -3 and the common ratio is -2. So the first thing we're going to do is write down the formula, and then we're going to plug in the information that we're given. So we're going to have the 6th term would be A6, and that's going to be -3, the first term, times the ratio -2 to the 6 minus 1 power, or the 5th power. -2 to the 5th power is -32, multiplied by -3 gives us 96, so the 6th term would be 96. Here is a problem to check your progress. Really easy process. This time you're going to find the 5th term of the sequence. Go ahead and pause the video, work it out, and we'll see the answer on the next screen. Okay, our answer this time is B96. Example 2. We need to write an equation for the nth term of the geometric sequence below 5, 10, 20, and 40. So first thing we're going to want to do here is identify what the common ratio is, and that's 2. And you can find that either by dividing 40 by 20, or 20 by 10, or 10 by 5, or just seeing what you multiply by to get from 5 to 10, or 10 to 20, or 20 to 40. Plugging in the first term 5 times the common ratio to the n-1 power, that gives us our general formula. It's our equation for the nth term. In part B, we're going to find the nth term, the equation for the nth term, based off knowing the 5th term in the sequence and the common ratio. So this time, the first thing we were going to do is try to work backwards to find the first term in the sequence. So we know that our 5th term was 4, so we're going to plug in 4 over here. And knowing that that's the 5th term means that we need to use n is 5 and the common ratio of 3. 5 minus 1 obviously is 4. 3 to the 4th power is 81. And then solving for a1, the first term, you get 4 over 81. So once we know the first term, now we can go ahead and write the equation. The general formula would be an equals 4 over 81 times 3 to the n-1 power. Okay, here's a problem to check your progress. Go ahead and pause the video and read through the problem. We'll see the answer on the next screen. And the answer this time is choice C. First number is 3, and we're multiplying by 5 each time to get the next number in the sequence. For part B, go ahead and pause the video, read through the problem, and we'll see the answer on the next screen. And the answer for part B is choice A. The initial term would have been 6, and you have a common ratio of 2. All right, for example 3, what we're going to do is find missing numbers in a geometric sequence, and that's what a geometric mean would be. So it says we need to find 3 geometric means between 3.12 and 49.92. So the first thing you're going to want to do is think about how many terms are in between the terms you're given, and therefore also the total terms. There's 5 total terms in this case because there's 3 terms that are going to be in between the 2 numbers that we're given. Then we're going to use the last term as an. We're going to use the first term that we're told as a1, and since n is 5, we're going to divide each side by 3.12. That gives us 16 equals r to the 4th. Then you have to take the 4th root. That gives us plus or minus 2. And then you have to use just a little bit of logic to think about, does the rate of plus 2 or minus 2 make more sense? If you use positive 2, then you could get 6.24, 12.48, and 24.96. If you use negative 2, you could get negative 6.24, positive 12.48, negative 24.96, which would have then make the next term, the 5th term, positive 49.92. So in this case, both R values work logically as possible solutions to the problem. However, it's possible that that will not always be the case. It's possible that sometimes maybe only the positive ratio or maybe only the negative ratio will be the only ones that work. But in this case, both of them happen to work. All right, here's a check your progress problem based off the same concept. Go ahead and pause the video, work the problem out, and the answer will be on the next screen. Okay, this time the answer is choice A. The pattern, the common ratio would be 1/2, or thinking about it, that means you're dividing by 2 each time. All right, next we have a key concept for how to find the partial sum on a geometric series. And again, it's based off the information that you're given at the start of the problem, just like we looked at the partial sum for an arithmetic sequence in the previous lesson. If you are given the first term and the number of terms, you want to use this first version of the formula. If you're given the first term and the last term, then you want to use this version of the formula. And it's important to remember, based off these, that the common ratio cannot be 1. You can't just be multiplying by 1 each time. And just to note, if you were multiplying by 1 each time, it means that you would have the same number in series. So, for example, 4, 4, 4, 4. Each time you're multiplying by 1, then this formula doesn't work if the common ratio is 1. All right, so in example 4, we're going to be applying the partial sum formula. The problem says, Julian hears a song by a new band. He emails a link for the band's website to 5 of his friends. They each forward the link to 5 of their friends. The link is forwarded again following the same pattern. How many people will receive the link on the 6th round of emails? So in this problem, what we need to think about is how many times the emails are sent around and how many times the email is sent each round. So first off, it says that 5 emails are sent in the first round, and there's 6 rounds of emails. So if there's 5 emails sent initially, the first term in the sequence is 5. And because you're sending each time, each person is sending 5 more emails, that means the common ratio is 5. And because it's being sent out 6 times, that's n. That's the number of rounds of emails that are going out. So we are going to be using the first version of the formula because we know the first term, a1, and we know n. So the sum formula says that we take the first term minus the first term times the ratio to the n power, and we divide by 1 minus r. So plugging in the information that we're given, you can see that they did that here. We're going to simplify that on the next screen. We get a sum of 19,530 people. which is why, coincidentally, chain emails and forwarded emails are so obnoxious if you get them in your email account, because they spread so quickly, and you might get them multiple times, and they're a big annoyance if you're in the workplace. For people, if people are sending out forwards, your boss could get annoyed with you because you're clogging up an email system, because you can see that the number of emails that get sent out grows very quickly. Anyway, so there's 19,530 emails sent after 6 rounds. We've got a check your progress problem. Go ahead and pause the video and read through the problem, work it out, and the answer will be on the next screen. Okay, this time we have an answer of choice D. 3,279 people will receive the emails on the 7th round in this scenario. Okay, example 5, we're going to work through a geometric series based off sigma notation. So again, from last lesson, we learned that this symbol sigma means the sum. We're starting from when n equals 1 all the way up to when n equals 12, and our formula that we're looking at is 3 times 2 to the n minus 1 power. So we're going to start off this time. There's a couple methods that we could choose. The first method, since we're looking at a geometric series, you can use the sum formula. We're going to want to find the first term, the common ratio, and the number of terms. In the first term, that's when n is 1. That's the first number you're plugging in. If you plug in 1 into this formula, you're going to get the formula simplifies down to just the number 3. And the r is 2, the ratio. That's the common ratio right here. And there's 12 terms because you're going from 1 to 12. So based off that, plugging the information into the formula, simplifying down, you get that the sum is 12,285. The second method is basically just doing it all out by hand. It's going to take you a lot more time. This shows all the work here. You get the same answer, assuming you do your math correctly, but this is much more tedious, so I would not suggest that you use method 2. Okay, we've got a check your progress problem. Wow, I think they skipped over the question. Yes, they did. Okay, well, here's the answer. But you should still pause the video and see if you can get this answer on your own. This time you're going the sum from 1 to 4 of 5 times 3 to the n minus 1 power. One more example, example 6. This one, we need to find the first term in a geometric series if we know the sum, if we know the number of terms, and we know the common ratio. So this time, again, we're starting with the sum formula, the first version of the sum formula. We know the sum, we're going to plug that in. We know the common ratio is 2, we're going to plug that in everywhere we see r. And we know n is 8, so we're going to plug that in for the n in the formula as well. Once we plug that in and simplify down, we get 765 equals 255 times a1. We're going to divide each side by 255, and we get a1 is 3, so the first term in the series is 3. And we've got to check your progress problem for this as well. Go ahead and pause the video, read through it, work it out. Answer will be on the next screen. And our answer this time is choice B1. The first term in this series is 1. And that brings us to the end of the lesson.